This lesson is parallel lines and angle pairs, and our learning target is I can solve problems using parallel lines and angle pairs. So like most of geometry, what we're going to do is we're going to talk about a vocabulary word. We're going to learn a theorem, which is just a true statement that's always true, and then we're going to do an example. Okay, so first thing you need to understand is what a transversal is. So a transversal is a line that cuts two parallel lines. Alright, so if these two lines are parallel, if you see this little symbol, that means parallel. Also, they could do something like, if I called this one AB and this one CD, maybe in the problem, they would just write this. So if you ever see this symbol, that also means parallel. They mean the same thing. So a transversal would be like something like this. So it's just a line that cuts two parallel lines. That's all it is. Okay, but here's the thing you need to know. If a transversal cuts two parallel lines, then 8 angles are formed. These pair of angles have different names and properties. So here are my angles. 1 would be this one. 2, 3, 4, 5, 6, 7, 8. So that's where I'm getting 8 from. Alright, so in our example, we're going to identify the parallel lines and the transversal. So, if you'll notice, these two angles down here are the ones that have a value in them. So, the two parallel lines must be these two. So, AB and CD are the two parallel lines. Also, notice you got that little marking on it. Okay, so if those are the two parallel lines, then the other line that's making that angle would be BC, and we would say BC is the transversal. So remember that the parallel lines being cut by the transversal, I just spelled that wrong, I just realized, are making up the actual angle. So here were the two parallel lines, and this one was the transversal because you had these two values. So that's why you didn't use that line AD at all, because you weren't talking about any angles being made from parallel lines in line AD. Okay, so here's some different angle pairs and their names. So same side interior angles are angles on the same side of the transversal, and they're on the interior of the parallel lines. Okay, so here's what I mean with that. Here's the parallel lines. Here's the transversal. So angle 1 and angle 2 would be same side interior because they're both to the left of the transversal and they're both inside the parallel lines. Also 3 and 4 would also be another pair of same side because they're inside the parallel lines and they're on the same side of the transversal. So here's what you have to know about them. Same side interior angles are always supplementary. And if you have forgotten, supplementary means equal to 180 degrees. So same side interior, supplementary. They all start with the same letter, so it's kind of easy to figure out. Okay, so if we're looking at an example, you got those little markings. There's 2 of them. Don't be fooled. That means parallel. And we're talking about this angle and this one. Notice that they're both inside the parallel lines. They're on the same side of the transversal, so those are same side interior. And since we know that same side interior are supplementary, we can add them together and we can set them equal to 180 degrees. So that's what we have to do. Alright, so I'm going to get my like terms together. I'm going to move the positive 4 over by subtracting 4 from both sides. And then I'm going to get rid of the 44 by dividing by 44 on both sides. So 176 divided by 44, x equals 4. Alright. alternate interior angles, they are on alternate sides of the transversal, and they're on the interior of the parallel lines. So here's two parallel lines. Here's my transversal. 1 and 2, they're on alternating sides of the transversal, but they're inside the parallel lines, so those would be alternate interior. And then also 3 and 4, they could also be, because they're on alternate sides, but they're on the interior of the parallel lines. So alternate interior angles are always congruent. They're always going to be equal to each other. So if I look at my example, I have this angle and this angle. They're on alternating sides of the transversal. They're inside the parallel lines, so they must be congruent to each other. So all I have to do is set them equal to each other. And I'm going to find x by subtracting 139. So x equals -7. And that's completely fine that a variable equals a negative number. An angle can't be negative, but a variable can. Alright, so people have a hard time with this one. So these are corresponding angles. So corresponding angles are on corresponding sides of the transversal, and I'll show you what I'm talking about. So here's two parallel lines. Here is a transversal. 1 and 2, they correspond to each other because they're both like the exact same angle, just kind of moved down. So those are corresponding. 3 and 4, they're the exact same angle, just kind of shifted. Let's see, 5 and 6, they're both the same angle, just shifted. And 7 and 8, both the same angle, just shifted. So the thing you need to know about corresponding angles, they are always congruent. Alright, so if you look at the example, you have this angle and this angle. Notice they're the exact same angle, just shifted down, so those are corresponding, which means that they're congruent or equal to each other. So if I wanted to find x, I would move 5x over. X equals 10. Alright, so these are called alternate exterior angles. They're not used as much, but you will see them from time to time. So alternate exterior angles are on alternate sides of the transversal, but they're going to be the exterior of the parallel lines. So if here are my parallel lines, here's my transversal, like 1 and 2. They're on alternating sides, but they're outside the parallel lines, 3 and 4. Alternating exterior angles are always congruent to each other. So if I look at my example, I have this angle and I have this angle. They're on alternating sides of the transversal. They're on the outside of the parallel lines. They have to be alternate exterior angles, but we know that those are congruent. Also remember that this symbol means 90, so I'm going to set them equal to each other. I'm going to get rid of 6 by subtracting, and I'm going to get rid of 21 by dividing, so x equals 4. Okay, so that's a lot of stuff to remember. All of them are congruent to each other except for same side interior. Same side interior are supplementary. So that's the only difference. So go ahead and try your problems and let me know if you have any questions.